Hey everyone, and welcome back to the Firefighters podcast, where we seek to develop, inspire, and motivate the world of the emergency services operator through a series of wide-ranging conversations. Now, before we go any further, just hit that rate, follow, or subscribe button on whatever platform you're listening to. It's a key performance indicator for us and helps us reach even more people. Now, here's what we've got for you today. Welcome back to another episode of the Firefighters podcast, where we delve deep into the science, stories, and the innovations that shape the lives of those who risk it all to keep our community safe every single day. In today's episode, we're going beyond the flames and exploring the lifespan of firefighter fabrics as we're turning up the heat on groundbreaking research from the University of Alberta. Now, joining us on the podcast are two incredible experts: Saiful, a PhD candidate who spent the past 4 years uncovering why firefighter gear doesn't always stand the test of time, and Dr. Patricia Dolez, an associate professor and leader in textile science. Today we'll take you behind the science of their cutting-edge work, uncovering the hidden factors that can weaken your protective clothing. We're talking moisture, heat, and even the chemicals that linger after a tough call. You'll hear about the science of fabric degradation, tensile strength, sulphur content, and water repellency breakdown. The unseen dangers of chemical leaching and how outdated testing standards put safety at risk. And exciting new advancements as well, like sensors that can monitor gear aging in real time and revolutionary cleaning methods that outshine the old school wash. Now, this episode is packed with crucial insights for firefighters, researchers, and anyone passionate about innovation in safety. Together, Saiful and Dr. Dolez will help us understand how we can better protect those who protect us. So grab your gear, grab a coffee, and settle in. Get ready to explore the science behind the equipment that keeps all of us safe on the line every single day. I'll see you on the other side. So Saiful, when you first reached out to us, what was the driving purpose behind you reaching out? Because when I started reading those elements of the aging of firefighters' protective clothing, there's a lot of stuff going on around the UK and especially in the States. I think the States are actually a little bit further ahead than we are about what's in these things, how long do they last, how protective are they actually making us? What drove you to start your research with this?
Yeah, so one of the things about the aging of this type of material is that the high performance fiber are very expensive and known for its superior performance, right? But if you go to the literature, barely there are data about how this type of fibers or the fabrics behave in long term. And if you search, you'll find only a handful of articles where they study different aging behavior, but not very comprehensively. So for me and my team, it was the motivation to investigate as much deep as possible to figure out what is really happening, like decoding the behavior of this type of fiber. And if I say about why I reached out to you, one of the things in terms of research, we are doing research in different universities, for example, here at UFA. But why are we doing this research? To help the society, to make a positive impact. And to help the society, we have to spread the knowledge, right? And spread the knowledge to the end users. And I thought a podcast talking with you, you are a firefighter, right? It would be an excellent opportunity for us to spread the knowledge directly to the consumer who are using this type of fabric.
Mate, I absolutely love that. There's nothing more frustrating for me than, academics are my favourites to speak to, because speaking to other firefighters and even first responders, paramedics, police, whatever, it's great and we high-five each other about our real-world experiential learning. But where we struggle is crossing that chasm into the academic world and really putting some rigour of research and data behind some of our feelings, if you will. Some of our feelings, some of our sensory inputs where we're like, something's not quite right here. Or we're scared, honestly, certainly when it comes to our PPE, our bunker gear, our fire kit, about is it what it says on the tin? Because ultimately, with the greatest respect to the manufacturers, it's becoming very emotive out there. It's becoming very scary. Certainly in the US, there is a great deal of litigation and concern around the safety of these things. So Patricia, for yourself, what was your role in this? Because I understand you're a textile scientist. Help us understand a little bit around the role you've played in supporting and working alongside Saiful and kind of your background, if you could. This episode is brought to you in partnership with Godiva Limited. Godiva is one of the world's leading providers of specialist equipment for emergency services market. Renowned for innovation, quality and reliability, Godiva produces a comprehensive range of fire pumps, including vehicle-mounted, portable, and their cutting-edge integrated total water flow control system, SAMFlows. I've been using Godiva my entire career. as a reliable pump on the fire ground. It is such a crucial element of a successful firefighting team that you want to empower your crews with the very best, reliable, quality product. Reach out to our partners by checking the notes in the podcast. Now back to the show.
My background is in materials engineering. I have a PhD in physics. And in fact, textile has been coming along. I've sort of learned by experience. I'm teaching textile or textile science, but it has been come through my experience of working with protective clothing. So I've been working in the area of protective clothing for about 20 years. And I've been working on the topic of the aging of fire protective fabrics, more specifically for firefighters for, I would say, 15, 17 years. And initially, we had some discussions with firefighters. I was in Montreal at that time, which sort of raised some questions about, okay, how durable their things are, how long do they last? And then we started doing, some investigation, a first PhD student. And then when I left, École de Technologie Supérieure, where I was doing that research, there were a lot of questions left. We had identified there were issues, but we know what was the root cause. And when you don't know what is the reason, you can't really, find a solution. So a few years ago, so in 2017, I joined the University of Alberta, and I was able to sort of restart that research on the aging of fire protective fabrics. There's a long history of relationship between this department and the area or the sector of fire protective fabrics. There's like the oil and gas industry up north. And so I was able to restart this research and in particular with Saiful to sort of go more in depth or have a more thorough investigation. And then we found out, some explanations to the things we had identified. And in fact, the industry even has been, pointed out, but then, they couldn't do anything because they didn't know why. So that's a bit the, trying to, and I will sort of like support what Saiful was saying in terms of why we're doing this. So firefighters, there is a life to help protecting us. We want to be able to help firefighters remain as safe as possible. And that's one thing with, the testing that is performed on the fire protective gear is that it's tested at the time it is, like in the brand new state condition, but then they say 10 years, like the NFPA, so in the US, they say 10 years, but this is sort of like anecdotal, like sort of history-based data. But when you consider that now, for example, NFPA has increased to twice a year the recommended washing because of the problem that has been identified of these toxic chemicals getting into the fabric, and then and now they're talking of increasing further that frequency. And I think in Europe they're maybe a bit ahead of us and talking, maybe having started to implement washing after each time people are coming back from the and then
after every exposure,
so in NFPAs are not there yet, but they're going there. And the problem is then we have no clue how long the garments are gonna last. And that's really where we're trying to help generate the data to be able to have a better idea of what's happening.
Yeah, just to add it, Patricia, a little bit. Patricia was saying about the testing, right? And about NFPA. And if you go to the NFPA, you'll see that all the testing on the new fabric, of course, on the new fabric, and there is no consideration for the aging of the fabric. While the fabrics are new, they have different testing. They have a moisture barrier aging test, but there is no test for the outer shell one, which is the more exposed. Yeah, if you go to the NFPA 1971, you'll figure out.
Yeah, and even for the moisture barrier, So they're asking for UV, and you're thinking about it, why, UV, that moisture barrier is sort of screened, between the outer shell and thermal liner. And I recently learned about the explanation. I think I forgot if it was it was during the PhD defense of Saiful's colleague, so another PhD student doing working on the moisture barrier, the aging of the moisture barrier, and we learned that it was because some firefighter station, when they let the garment dry after washing or when it's wet, to just open it and let it dry like on the outside in full sun. This is why they had this. And in fact, at the moment, based on my understanding...
But again, that UV exposure is not actually to the moisture barrier itself, is it? Because that's within the multi-layers of the fabric.
They would open it. So they would take out...
unzip the bottom.
They would spread, the 3 layers on the trucks to make them black, which is not a good idea. We completely agree with that. But that's sort of like what I've been told, or we've been told. This is the reason of that UV test, and they're gonna, based on my understanding, they're gonna remove it. So there will be nothing left at all, even for the moisture barrier. But as Saiful mentioned, there's nothing for the outer shell, and the outer shell is sort of like the first line. It's the most exposed.
This episode of the podcast is brought to you by Gore-Tex Professional Fabrics. Now, we all know the working environment of a firefighter is filled with challenges. We face serious risks on the job, such as heat exhaustion, burns, physical and mental stress, and we frequently come into contact with high levels of toxic chemicals. Now, I have been wearing Gore-Tex for nearly 2 decades on the front line, working in hostile environments, tackling challenging incidents from firefighting to water incidents and in urban search and rescue environments. Gore-Tex have a well-earned reputation for protecting professionals in the fire and emergency services through their family of highly innovative, waterproof, breathable moisture barriers that exceeds global performance standards and are trusted worldwide. Gore-Tex, going further together. I'm a knuckle-dragging firefighter, so try and help me understand, if you can, the logic behind why we wouldn't test the longevity of it over time. Because in some of your research, Saiful, you were saying that one of the studies revealed that some of the fibers used in the protective gear break down when exposed to warm water. That rings alarm bells, because anyone's standard approach to washing clothing is warmer, faster, hotter. If something's dirtier, warmer, faster, hotter seems to be the generic approach. I mean, there's a lot of work being done with a colleague of mine, Hunter Apparel, Simon Hunter, with the LCO2 decontamination, which looks to... Are you familiar with the LCO2 stuff?
Yeah.
Yeah. So they're obviously attempting to, get around the warm water element, on top of the fact that washing them in that fashion doesn't actually remove the vast majority of the toxins anyway. But take us through the studies that analysed the effect that the water had on it. And there was one around the harmful dyes that were being done as well. If you could just break those down for us, Saiful, and talk about the fibres that were used during the protective gear and their exposure to water, and kind of the stages of degradation, if you will, and if you managed to come up with any data for how long we could suppose these things will maintain their claimed protective elements to it.
Yeah, so particularly for this study, we tried to simulate like warm water condition. And did the aging, like accelerated aging, to figure out what is happening for different types of fiber blends. So we did a study which comprised all the high performance fiber which are typically used in the firefighters protective clothing: aramid, PBI, PBO, Technora, all the high performance fibers. And we wanted to see how each fiber blend behaved when it is exposed to different types of warm water at as low as 40 degrees centigrade, as high as 90 degrees centigrade. And with a surprise, we saw that like even with the 40 degrees centigrade temperature, which is not that much warm, right? And with that 40 degrees centigrade temperature, the fabrics started degrading right after only few days of aging. If you go to my paper, you'll figure out only after 5 days of aging, the fabric has a significant decrease in its strength. And by doing different types of analysis, we figured out that one particular blend of fabric and particular fiber, which has been leaching some sulphur, which is coming from its residual manufacturing process. And this sulphur really makes the water acidic. And in turns, it hydrolyzes the fibers, and even hydrolyze the fiber which is in the blend, which is not really affected when it is without that sulfur content fiber. So it's really figuring out what is happening and what is the root cause. And regarding the long-term use, we are not at that point right now. Like we use some predictive model, Arrhenius equation to predict at low temperature behavior, but we did not predict so far what is the long-term lifetime for this type of fiber. That's the next stage, and Patricia can add. We wanted to compare this data with the real use data which we have in the literature. And eventually we'll be trying to figure out what would be the useful lifetime.
So when we're talking about elements of the performance degrading over time, what elements of the performance are we talking about? The thermal protection? Are we talking about the levels of particulates that can penetrate through the garment? Because you said, it's not visible to the naked eye. So, when we look at generic clothing, obviously we see that the color starts to fade or it starts to feel thin or things like that. Those obvious indications aren't something we'd pick up from when that immediate performance starts to become reduced. So what elements are actually being reduced in terms of its performance?
Yeah, and you rightly pointed out there is not enough visual indication to say that this fabric is not useful anymore. And that's the main puzzle and main problem for this type of problem. And particularly, we wanted to see how the mechanical performance degrade and how the water repellency degrade. Because based on the literature, we did a very thorough literature review, and we figured out that the mechanical performance is the main factor or performance criteria that get affected due to the aging. This fire protective fabrics or high performance fiber we studied, or the high performance fiber which being used in the firefighters protective clothing, are inherently fire resistant. That means that as these fibers are inherently fire resistant, these are not usually get affected due to the aging. But that's not only the protection we want as a firefighter, right? You need the physical integrity of the clothing. You need water repellency so that the water doesn't get absorbed and you don't get second degree burn injury. So we figured out that these are the two criteria really get affected due to aging, and our main concentration in the study to figure out how they get affected. What are the criteria? What are the mechanisms to make it worse with over time?
So, Patricia, when you started to see some of the outcomes of these initial testings, what were the immediate concerns that sort of came to mind for you about the fact that, do you have any data on how long firefighters are being issued this equipment for? I imagine when, services or organisations engage in contracts, they will be over fixed terms. But I know I go to a lot of training facilities and colleges where they will specifically use older firefighting bunker gear because they're going to be exposing firefighters to very hot, very carbonaceous fires, and they don't want them using their own kit, so they tend to use old kit that they've purchased from a manufacturer of some form. What's the sort of aging that is at the minute considered to be safe, and how long these firefighters are being issued it for? This episode is brought to you in partnership with MSA Safety. Today we have them to thank for the improved firefighter safety through connectivity in their brand new connected firefighter system. At the center of the connected firefighter platform is the MSA M1 SCBA with telemetry. That integrates straight in with the Luna system, which is a wireless all-in-one device creating an independent search and rescue network, providing edge detection, enhanced personal thermal imaging, while simplifying post-scene reporting and data retention. All of this then plugs into the FireGrid system for cloud-based connectivity, real-time information, and data-driven decisions for the incident commander. MSA are truly taking massive strides in the future of improved firefighter safety through connectivity in the brand new MSA Connected Firefighter platform. Now back to the show.
In fact, you're raising a good point. The difficulty, and maybe that's why the different standardization organizations are not feeling comfortable already to be more specific and include some requirements in terms of aging, is that you can, and that's what we've been doing, using accelerated aging treatments to get like the variation of the performance over time, simulating the type of aging conditions that will be encountered in the field. But there's a big step between getting an indication that there's a loss in performance and being able to predict how it's going to happen in the field. So this is what we've been.
Would it be unfair of us to extrapolate a number based on initial testing? As an example, over 10 washes, it shows a reduction in performance of X percentage, and therefore extrapolating that over 50 washes.
So we wouldn't extrapolate, but we can run 50, and I've been doing some studies with 50 washes. In fact, Saiful, it's not published yet, but there's one paper soon. He's working on it. So I would say, in a sense, washing is one that is a bit easier because one wash, two wash, one wash, two washes, etc. But if you go to thermal aging, effects like exposure to heat, exposure to UV, how much a firefighter is receiving, it's going to depend a lot on the type of condition, and you can't predict because it's going to be different for different firefighters, for each firefighter. And then so there's sort of like some firefighters have more like that type of position, but even from one day to another. And then there's another factor, is that you are not just exposed to one thing. You are exposed to a condition of things. And then how do all these conditions sort of combine with each other? So Saiful, in his thesis, has been studying, looking into it. Okay, what happened if I combine UV and heat, or moisture and heat? What happens? So what is a synergy? But that's a whole thing that makes it sort of not easy to provide a response. But we're very lucky. The students at the University of Kentucky did a thorough study over 10, 12 years, where they tested some garments that had been used, and so they measured used for different period of time. So some were in fact still in use, some had been used and were retired, and they tested them. And so at the moment, we have one student who's starting the work on combined aging, so trying to combine different conditions. For example, saying, okay, I do some heat, and then I'm going to do a wash, and then a heat and a wash. So trying to sort of get closer to real conditions, and then we're going to see how it looks in terms of reduction of performance compared to this sort of data from used garments, knowing that there's a caveat with this data from used garments, is that we still don't know how much is being used, because this is a time from the time they were manufactured. So
you don't know the life cycle of the garment itself is the challenge.
Exactly.
But the manufacturers themselves will already need to accept the fact that the spectrum of usage and environments in which they are used is already a very wide spectrum. And again, I would never pretend to tell an academic how to study, but for me, I would just take dip samples of 1 year, 3 year, 5 year, 10 year, because for all intents and purpose, you can still say, look, this is an operationally used garment. Mm-hmm. Whatever that statement means, it's a big wide spectrum, but it has been worn. But I would imagine there is a reluctance from brigades, services, fire departments to volunteer their bunker gear, their PPE, their firefighting protective gear, because we might be scared of the answer.
And it's also a big cost factor. I would never be able to.
It's not huge. What, to give you a set of kit? If I gave you 10 sets of kit?
Yes. And
couple
then,
of £1,000 per kit. If one firefighter gets cancer, and there are thousands and thousands out there with it, it's going to cost that department $300,000, something like that, probably more, to pay that person out if they can prove that it is down to an occupational risk, which it already is. You know, the World Health Organization's declaration that firefighting is a carcinogenic profession. We kind of can't keep ignoring this for much longer, to be honest, and I'd argue we've already passed that point quite some time ago. The science, thanks to individuals such as yourself and many more around the world, the data is somewhat undeniable. So there are still some people, and I would argue they have a financial incentive to want to deny this and throw stones at your research and claim that, oh, well, you know, Saiful, Patricia, who are you? You don't know what you're on about. Where have you got this stuff from? Oh, that department, they don't really do anything. That's not really an accurate study. I'm sure there'll be lots of people willing to throw stones at that, but the ocean of data is becoming somewhat unrefutable now.
So I can share one interesting experience. So recently we had one paper, so it wasn't a paper of Saiful, on aging of firefighter bunker gear that was reviewed, by journal. And one of the comments of the reviewer was, there's almost no data. Do a more thorough. There's almost nobody in the world working on this. So do a more thorough, literature search. And so we responded, we say, I'm sorry, there's, not that many people working on it. And then the response was, oh, then it means it's something of no interest, just find another topic. I thought it was very interesting.
It is beyond a privilege to be able to bring the Firefighters podcast to you, and we are so grateful for every single person that supports, listens, shares, and follows our journey. But here's the honest truth. It takes a colossal amount of time, resources, the team, and work to keep the podcast going. And to help us keep doing it, create more, reach more guests internationally, improve the visuals, and make the podcast sustainable, we're asking for you to help. And to do this, we've set up a Patreon page. Now, by joining this, you'll not only support the future of the podcast, but also gain access to exclusive benefits. Now, if you've ever wanted to meet a member of the podcast, buy us a beer, buy us a coffee, and you think anything you've ever listened to on the podcast has been worth £3, that's basically what we're asking you for. By joining our Patreon community, you will get access to every single full episode archive we have ever made. Now, hundreds and hundreds of key documents that we've got in there on fire behavior, firefighter health, cancer risks, incident debriefs, and so much more. A growing collection of valuable resources to help you learn and grow. Now, I've only ever featured 200 episodes of the podcast on every free public available platform. You won't find the entire library because it is inside our Patreon. That is the full library legacy, and that is what you're joining for as well. So by joining the Patreon for just £3, you'll unlock everything we've ever created alongside discounts on merch like our coins, our hoodies, our patches, our tallies, and all the other stuff we're trying to crack on with doing on the podcast. Your support in whatever way, dropping it in the WhatsApp group, sharing it on the local newsletter, whatever it is, it's incredibly valuable, and we really do support it, and we need it to make it a long-lasting resource, that legacy resource we always talk about for first responders, firefighters, and everybody everywhere who's ever been interested in joining the fire service or who absolutely loves the job. Now, if you're already supporting something, as many people do, it's totally cool. You can still access the podcast for free, and you'll always be able to access all the new episodes for free. But we're asking for your help to make this sustainable. You can still listen, you can still join, you can still share it with your community. And if you want to do something free, follow us on our YouTube, subscribe to it, rate us on Spotify, whatever platform you listen to. We've reached nearly 1 million people with the podcast so far, which is just ridiculous. And we want to keep growing, we want to keep sharing the insights, and we want to keep showcasing the incredible work happening in our community and our sector every single day. So if you feel like you want to join the Patreon crew and help us make this possible, head to patreon.com/TFFPC or check the link in any episode podcast notes. Thank you for being here. Thank you for supporting us. We'll see you on the other side. Yeah, that's my frustration, is admittedly, there's probably not a lot of money available to contribute to academic studies in this nature. But I always say, we haven't got enough money to do it right once, but we seem to have more than enough money to do it 2 or 3 times. And like I say, paying those individuals and their families for, oh, we're sorry. Yeah, you're right. Maybe it was a little bit of our fault. Because once you confront that reality, that potentially firefighters are being exposed to things, and we haven't, that safer person concept, well trained, well equipped with appropriate PPE. If we as an employer aren't completing that circle, it's a very uncomfortable, and it's not just all the people that are out there currently wearing it, the torrent of people over the last 60 years that are going to come forward would cripple some governments and certainly departments. So yeah, I can appreciate that there may not be a tremendous appetite, and people may even be actively discouraging people from putting research into this area. But I, for one, am eternally grateful for the work of yourselves and many others out there. So you've done some initial studies in terms of water, in terms of exposure to water. Talk to me about the dyes again, Saiful. So obviously these materials go through a series of dyeing and stuff like that. You mentioned a few chemicals that don't come easy to my mind. So just help us understand how they can play a factor in the aging of these garments.
Yeah, so in terms of the dyeing, or I'll talk about the dyeing only. Dye doesn't interfere that much with the aging of these fibers, but the study we did, we tried to see what types of dye are leaching from this type of fabric when aging with the water or simulated like laundering. And we figured out that some of the dyes, which may not be environment friendly, may have some restrictions, and our studies showed that we would recommend to not use this type of dyes in this type of clothing. But so far, we did not figure out if the dyes affect the aging. That's the study was to see what dyes are leaching with the types of aging. Not only dyes, what types of chemicals are leaching as well. So this data also will be helpful for the developing new product and to figure out what to replace to make it more durable. And also, I just want to add with the previous conversation about the costing you were talking, that one of the aim of the study is to decode the behavior of aging, not to show that all fabrics age very fast, we cannot use for 10 years. Our study shows that some of the fibers are really good for some particular condition, and you may use it for a long time. And some of the fibers is not good. So this study shows that for some particular use, for example, when you consider about the water exposure, right? Meta-rabbit fiber turns out very resistant to hydrothermal aging or exposure to water. So if you go beyond firefighters, these fibers are used in different other clothing or manufacturing conditions, right? This data also going to be helpful for other particular field as well. And maybe some of the fibers are being used in clothing for 10 or 5 years, but our data shows that maybe it can be useful for a long time. And in terms of finishing, our study shows that some of the finishing are really degrading fast, right? So the manufacturer gonna get this information and can twist some tweak some good fibers, a good finishing. So yeah.
So those elements that we're talking about there are specifically built around the effect of warm water. We mentioned a little bit earlier around options that are available for cleaning contaminated kit that don't contain warm water. Now, I imagine there's not been a great deal of testing there, but talk to the element of, our archaic approach to always using warm water to wash things, and perhaps if that may or may not be the most appropriate manner for protective equipment and firefighting.
Yeah, I just want to, I'm not fully sure I understand your question, but I'm just going to rephrase to be sure that I understood. So what you are asking is if there are some consideration into looking for alternative method for washing regarding,
such as this LCO2 work that you see starting to be promoted by different companies, not just one company across the world. I think originally this came in under the manner of correct and full decontamination because washing with warm water, because of the moisture barriers involved in these highly technical garments now, there's still a lot of carcinogenic properties and toxins still being held within the garment, but it's supposed that with LCO2 decontamination, it removes significantly more of these harmful chemicals.
Yeah, and yeah, I've seen it started. I'm not, hugely familiar, so I don't know how available it is. From my
I
understanding,
think it's quite expensive. I think that's the problem.
That's what I was referring to. The infrastructure maybe a bit like setting it up. So I don't think for the moment it is available. I haven't looked into it, but I haven't seen if there are any studies looking at the long-term effect also on the on the fabric, on the fibers. So I would say that's two things. I can't really say yes, no. It's just like two things that before, running into this, it's very interesting to consider, but there are things to be checked. I suggest, I think it's important to check before making a transition. And in terms of cost, sometimes it's a question of if you just have a few users, then it's very expensive. If at some point it gets, like it becomes the only or known as the only solution that removes, all those toxic contaminants that are in the garment. And I was told at some point that the moisture barrier is the worst, as catching all of them and doesn't release them. And I mean, easily when washed. So that's, at some point there's some trade-off, as you said. Okay, are we going to keep on seeing the firefighters, getting sick, getting cancer, or are we going to do something? And then, if there's sort of like more of those machines, then probably the cost will decrease. But at the same time, I haven't seen a lot of studies, but I haven't looked for them that would see what would be the long-term impact on the garment, on the fibers.
The team here at the podcast are extremely excited to announce our brand new partnership with Patrol Store UK. Patrol Store has been serving the UK's police, fire and emergency communities and first responder sector since 2008, providing leading brands such as Hikes, Magnum, 511, Nebo, Opzulu, Highlander, AKU and many, many more of our favourites. They are now also supplying bespoke uniform, PPE and station workwear to fire services around the UK. So for all our listeners that are part of your USAR, your HEART team, your ISAR team, your armed response teams, your fire investigation, your NALO, your hazmat and all of the training departments that have got your own budgets, be sure to get the absolute best for your team at a realistic price by contacting Aaron and the team at Patrol Store and referencing the Firefighters podcast. Patrol Store will also be taking part in our listener competition giveaways, as well as providing unique discounts to podcast listeners. So for people that are always asking about Hikes boots as an example, that is one unique discount code that is coming to you very soon through Patrol Store. We've also got some incredible bags. I mean, the Opzulu bags are a game changer. So the really Gucci and expensive tactical black bags that everyone's using in CrossFit workouts and taking to the gym and taking to stations? Well, they've basically got that, but it's made better and costs less, because they're not slapping some Gucci expensive brand name on it and it's giving you what you want on a first responder salary. Be sure to keep your eyes in the notes of the episodes for links to unique offers and discount codes. And if you're looking to buy well and buy once, be sure to get in the notes and head over to Patrol Store UK. Now back to the show. In some of the information you sent over, there was an element about this sensor that can help detect the firefighter protective clothing is no longer safe. Could you speak to that around what specifically sort of the purpose of this would be, how its application, how you envisage it would be used, and how it would help us to track the degradation of a garment?
Yeah, so this project was started, I think, 6 years ago, when I learned about this discussion with an FPA going to increase the frequency of laundering. And then, what made me think, okay, they've been, gathering data for 30 years, 40 years to get to that 10-year retirement period with one wash a year. But now, if, you're changing the frequency of washing, and I knew from previous research that I had done before that, exposure to hot water was creating a problem for some of the fabrics. then you're not going to wait for another 30 years before deciding what would be the retirement time. So that's where I sort of had a brainstorming session in front of a whiteboard with a colleague in chemical and materials engineering, so who was looking at graphene, and then we combined our both expertise, and then we came up with this strategy of having a sensor on the fabric because as Saiful mentioned, you can't tell. Even when you're using a scanning electron microscope, there's fibers, even when they've lost 75%, or the fabric has lost 75% of its strength, you can't tell by looking at the fibers that they've lost their strength. When you were talking about the fabric becoming thin or losing its color, this is abrasion. This is a different type of aging condition. So the problem is that, with the sensor, what we're trying to do is, or what we're doing, is that we are finding another polymer that will degrade at the same rate as the high performance fibers or the fire protective fabrics. But the particularity of this polymer is that it will crack when it degrades. And then on that polymer, we have a layer of a track of conductive material, graphene, that in fact we're creating directly from the polymer. So the principle of that sensor, which is positioned like, there's one or two on your protective garments at, well located locations. So figure out what is the best location so that it doesn't interfere with the job, at the same time get, sort of like a good exposure. And then when the garment will get exposed over time, so it's really accumulation of exposure, the polymer of the sensor will degrade, start cracking, and then when it starts cracking, it's going to disrupt the conductivity of the conductive track. And then, firefighters at the end of each exposure, I can't find a word, but whenever you go, on a call, after you get back, you check your garment. And then what you would do is you use just a simple multimeter, same thing you have at home to check, your batteries. And then you just measure the resistance of the sensor. And with this, you're able to track what is the residual performance of that conductive track that will indicate what is the residual condition of your garment. So you don't have to wait for 30 years to know, when the thing is going to degrade. And it's also what we were mentioning before about the fact that different firefighters are exposed to different conditions. So in this case, each garment is tracked individually. So you're not trying to get like an average exposure and predict based on that. You're tracking what really each garment is subjected to, so the sensor remains there during washing. So it's really, in fact, the sensor combines three modules. There's one module that is with a polymer that is sensitive to heat. One sensor or one part of the sensor with a module that is sensitive to moisture, and then one part that is sensitive to UV radiation. And then with this, you can, because some of the high performance fibers are more sensitive to moisture, some are more sensitive to UV. So you are also sort of selecting the sensor or adjusting the sensor so that it's going to be degrading at the same rate as the particular fabrics that you're using for your garment.
Mm. And would this information sit on a software platform where perhaps you could give some contextual information about the level of exposure? So as an example, I come back from an incident and I'm going to scan it, I'm going to do the test. Would there be an opportunity for me to input and give some information about the level of exposure, perhaps the heat or duration of time that I spent wearing this thing in a fire as an example, or if I've been to a water incident or whatever it might be? Because I imagine that would make the data significantly more useful.
So at the time, this is an interesting suggestion, and in fact, we are working with a firefighter training school in Quebec, and we're planning to do to field test their sensors, because currently there's one company here in Edmonton who has taken on to commercialize their sensors. So we're working with
Fantastic.
them for the scale up of the manufacturing. So this company has been involved. In fact, when we started the work 6 years.
Would it be appropriate to mention who they are? Is it not appropriate at this moment in time?
It's public. It's Davy Textile Solutions.
Okay.
And so.
Would you be able to provide a link to that after this? If Saiful, yes. If you could email a link, just so we can, for people that want to get behind this and perhaps volunteer themselves for some testing of some kind.
Yeah, and maybe Saiful, if you can share the link to the folio article, because they were mentioned in that.
I think you've already done that, haven't you, Saiful?
Yeah,
Is that the article I've already got?
Yeah.
Yes.
But,
so for the
no
listeners'
problem.
awareness, if they go underneath this episode, the links provided there are the ones from Saiful, and you'll be able to find some more. Sorry, Patricia, I interrupted you.
Yeah, no problem. It's a good point. And so what we're going to do during that field test is that the firefighters, the instructors of the firefighter training school, we are going to wear some sensors. We're going to put a bit more so that we maximize the results that will be generated.
I imagine because the positioning of it on the garment as well is one of those tricky elements that you want to make sure it's fair.
Yeah, and that's one thing. We also want to get data about where it should be best positioned. But we're working with a firefighter manufacturing company, so they also have some ideas based on what type of damage they get, because they also repair garments, so they can also help guide, in terms of what are the most exposed area.
There's a couple of elements for me. I mean, on the shoulders would be an obvious one, because that's where you get a lot of compression between the garment and where it's probably least effective to creating a thermal barrier, but also around the neck. So, we're stood up, and this is right at the edge of our flash hoods, fire hoods, different terminology. And we're always getting a full face of all sorts of carcinogens, and they're the bits that tend to be stinking and gassing off most, because it obviously sits highest on the garment itself. But certainly benefit from 2 or 3. But again, it becomes an affordability perspective as well, then, doesn't it?
No, so this is for the field test. So we will identify, and in fact, we had thought about the shoulder or the here, but we had not thought about the neck. I mean, we have a meeting in 1 or 2 weeks where we're going to discuss about the different options for the location, and then what we will do.
I'd suggest on the cuff as well, just for your notes. Because this is the bit where you're constantly getting bleed off the branch. This bit shouldn't be getting wet, but will more commonly be getting wet. And it's the bit that's interacting in all parts of the compartment. And it's just the bit that gets pulled around and probably damaged and interacted with the most.
The problem with the cuff is that it may be a bit too much in the way. So
how big is the sensor?
It's 5 centimeters. It's not big, but it's maybe pulled out. So, but I keep that in mind, and that's going to be. I mean, we're gonna discuss, and really the objective of that field test is, putting some in different locations. Ultimately, it's not going to be, there's not going to be that many, but for the field test, trying different locations, and then the firefighters or the instructors will wear it. So we will have like a vest made just for the field test, so a few ones, and they will wear the garment, be exposed. And the advantage of working with a firefighter training school is that they get a lot of exposure. So, instead of keeping it for 10 years, they keep it for 1 year, their garment. So it's an accelerated.
That's my greatest concern with a lot of our instructors, is the level of exposure that we get. It tends to be typically more than everyone else, with the greatest respect. Not that we're more or less important than anybody else, but just the level of exposure that we have on a very regular basis.
But
that's why when I've looked at the thermogenic effect, sort of long-term effect of heat stress, effectively heat stress and heat syncope and our thermal regulation, a lot of the best academic papers that I've read have always been done with instructors, fire behaviour instructors, because they're in there for longer, they're in there more often, and they're the ones at greatest risk, in my personal opinion.
Yeah, and the thing is that we don't want to wait for 10 years to get the result of this field test. So that's why we're doing it with them. But so that's where they're going to be able to document, write down what type exposure, so that we can track, okay, the sensor is doing this and they've been exposed to that. And then one thing also is that at the end of that field test, we will take out the garment and we will test their residual performance, destructive testing. So we're going to be able to match what the sensor has been tracking and what is really the condition of the fabric.
Love it. I'm really excited to see the outcome of that. It'd be quite nice to potentially have you both back on to speak about the outcomes of this. I want to be respectful of your time, but I'd be remiss, Saiful, if we didn't just try and cover off some of the other elements where we spoke about things that are almost within the person's sphere of control. Perhaps, in our initial conversations, we explored potential options for people to, or even recommendations, to enhance the safety and durability of these fire protective garments. Is there anything that we would suggest off the back of these initial findings that people could perhaps start implementing that's within their sphere of control, just as a preventative measure to try and steer them and their staff and their colleagues in a safer direction? If you're a regular listener to the podcast, then chances are you are big into your own personal development and the development of firefighters around you. So I wanted to remind you of our mobile app Drill Book. This is a free training and development resources made by firefighters for firefighters. Heading on to Drillbook, you will find incident debriefs, radio messages, knots and lines, quick reference guides, quizzes every single day. We've got useful links to the ERG, to Web Rescue, to JESU, Euro Rescue, 10-second triage, National Operational Guidance, and not to mention our daily quizzes where you will find questions on extrication, casualty handling, breathing apparatus, fire development, water rescue, rope rescue, you name it. It is the go-to resource if you've got a spare 5 minutes on the firehouse to develop yourself and those around you. Not only that, if you're looking to get into the fire service, we've got advice on there on interview questions, interview answers. You can build your own questioning in there. And again, remember, this is built by firefighters for firefighters, so you can add your own drills in there. You can pick the drills that you find the most favorite. There is literally hundreds of training ideas, hundreds of drills in there. Remember, this app is absolutely free and it grows every single day down to the contributions of our thousands and thousands of users. It's freely available on Android, Apple, and you will find it in the links for this podcast. Remember, it's called personal development. The clue's in the name. You've got to work twice as hard on yourself as you do on the job. So always be growing, always be developing. Now let's get back to the show.
Yeah, thanks for the questions. And before going to answer that question, during the discussion of the sensor, I really like this type of conversation because you had some excellent suggestions, right? And that is one of the beauty of working with Patricia, because all the projects, including this one, all are involved industry partners who are manufacturing this type of product, and also end users like firefighters. So this type of conversation I always look forward to, and thanks so much for all the suggestions, and it's gonna helpful for the future step of the research. And talking about the recommendations, yes, of course, there are a few recommendations from our side. The first one is regarding the standard organization like NFPA, right? I was talking at the beginning, there is no testing for the aging and our study, and so far we talked about only hydrothermal aging in a large scale. But our study, we did a study on the thermal behavior. We did a study on the UV behavior, how these things affect the fabric. We also studied the abrasion. The paper is not published yet. We also did a very thorough study on the laundering, like 50 cycles. We did a study on the combined, right? So based on all the findings, our first recommendation for the standard organization to include aging test for the fabric, because we have figured out not all the fibers, not all the fabrics behave similarly in terms of aging in different conditions. And based on our finding, we strongly recommend to include some testing for the aging. For the behavior of this type of fiber and fabric, we figured out some fibers are sensitive to hydrothermal condition, and due to some manufacturing process, we strongly recommend to revise this type of manufacturing process so that these fibers can last longer. And some of the fibers are really good in terms of textile characteristics, but few things are making it worse. And just for the manufacturer, we have this recommendation. For the safety, one of the things we already discussed before about the sensors, that's the group is actively working here to bring that into the market as soon as possible with reliable data. And that's going to be a large impact in terms of the safety of the firefighters, because you can track the behavior of the aging, because you cannot do any destructive tests on the fabric, right? In that case, this sensor is going to be really groundbreaking in terms of the safety of the firefighters. And I guess I will let Patricia to add if there is anything more.
No, I think you've covered quite a good number of things, and I think awareness is really key. You were mentioning that earlier, Peter, that the people are trying to ignore data and say, oh, I didn't know. But I think if people are aware of the situation, it's not a question of sort of getting scared, but it's really having the information and then being able to make informed decisions. And that's really, and that's why, your initiative is so great, because it's really, we're publishing articles, we're trying to, spread the word, to like end user community, when, in contact with manufacturers, with firefighters, but still taking advantage of any opportunity to really inform people about what's happening. And like, I remember a few years ago, I was talking with a volunteer firefighter, and they were keeping their bunker gear in their trunk, when they were going to work, in case they were. I mean, that's the worst thing to do, and so
I did it for about 12 years.
Okay. And
terrible. Picking up my children, after school and stuff like that, and they get in the car, they go, "Daddy, it smells. It smells. Have you had a job today? Have you been into a fire?" I'm like, yeah, oh, it's okay. We'll just open the windows.
Yeah. And so
honestly, it upsets me quite a lot to think about the potential damage I've done to my children.
And that's the thing. People, we don't, or people don't really know, or don't know the impact.
If we'd have known better, we'd have done better. Now that, through the support of academics and others, now we know better, we actually have the opportunity to do better, don't we?
Yes, and I think it's really working together to find solutions and having everybody around the table. So that's one thing I try to do in all my projects, is to have the industry, to have end users at the table, because everybody together can get to the best solution.
100%.
And so that's really the things I think is critical, and that will make the work of firefighters safer.
Saiful, Patricia, thank you so much for your time. I really do appreciate that. Is there any closing points, any bits you would like to revisit, any elements that you feel we perhaps not gone into enough detail to sort of leave our listeners with a closing point?
No, I think you covered with your questions.
Wonderful.
They were very good.
Absolutely love it. In which case, please send my love to your family, to the team and everybody like that. And I really look forward to speaking with you again soon. I think there's some exciting research that's going on, and I'd love to continue to support it from an awareness perspective. I really appreciate your time.
Thank you.
Thank you
so much.
The Firefighters podcast was created to recognize, acknowledge, inspire, and hopefully even motivate these incredible individuals who have chosen to be part of the first responder community. Our driving purpose is to create a legacy resource for the current and future generations of firefighters and first responders. We get some incredible feedback from listeners and guests, and as the podcast grows, our desire to create longevity and sustainability means that we are asking for the support of our listeners. If you want to support the podcast, if you want to get discounts to our merchandise, hoodies, clothing, coins, patches, tallies, and also access to all of the incredible documents get shared with us from our podcast guests and sector leaders, then please head over to our Patreon page, and for just £3 a month, you can support the future of the podcast. Please finally hit that follow, subscribe, or rate button on the platform you're listening, and wherever you're in the world, please support your emergency services responders, and thank you for listening.